Hello everyone, welcome back. Hope you all are doing great. Guys, today in this video, we are going to discuss IGMP protocol, Internet Group Management Protocol. We will see what is IGMP protocol, how IGMP protocol works, their messages and versions, and then finally configuration. This is my scenario where I will show you the configuration of IGMP protocol. After that, guys, we will also capture the link between devices to see the IGMP message. Okay, so this is all about IGMP protocol. And guys, I must tell you, IGMP is a very important protocol of multicasting. So if you are a network engineer or if you are planning to become a network engineer, make sure you will watch this video till the end. First of all, what is IGMP protocol? See guys, here IGMP protocol used by devices to join or leave a multicast group. It is used to join or leave multicast group. See, if you don't know the benefit of using multicast, then first of all, let me tell you the benefit of using multicast here. After that, I will take you to IGMP protocol. Guys, we are using multicast to reduce the CPU uses or the bandwidth uses. For an example, this is my scenario, and here you can see I have one video server. This server is streaming video, and let's say in the LAN side, guys, I have 100 users, and these all users are watching the video here, right? The video which is available on my server. So if the server is going to send same video to 100 user as a unicast, then the server have to generate 100 number of stream. It have to generate 100 packets if it is going to send the unicast message to all 100 user one by one. Yes, definitely. But in all the 100 messages, content is same. The message is same. Message is video. What is the difference in all the 100 packets or streams? Only destination IP address, right? Like my server will generate one unicast um, stream for PC1, one for PC2, one for PC3, and in all the message, all the packet information is same. That is video is same, right? So if the server is going to generate 100 number of packet for 100 number of LAN users for one video, guys, like this, I can have multiple video, right? Maybe this server is sending a stream on multiple broadcast, multicast group, right? Or this server has multiple types of videos, right? So for one video, it need to send 100 packet. It will generate 100 packet, right? And you know, whenever a device like this server will generate a packet, it will perform encapsulation, right? It is going to use their CPU, right? It will perform encapsulation at layer 4, layer 3, layer 2. It is going to use their CPU. Another issue is, first is CPU utilization, right? If it is generating 100 number of packet, or if you will compare that with one packet, then definitely here we can save lots of CPU uses. The another issue is bandwidth uses, guys, right? For an example, one video bit rate one video bit rate equals, let's say, 5 Mbps, 5 Mbps, right? So if the server is going to send 100 stream, right? So total bandwidth is going to be 5 multiplied by 100 for 100 user means 500 Mbps, right? This is the bandwidth uses of this link. Not only this link also, because here also we will have 100 number of stream packet, here also, here also, here also, correct? So to avoid this bandwidth uses or the CPU uses of router and even the server, even the router also, guys, router is going to process all 100 number of packet, right? Switch is going to process all number of packet. So we come up with multicasting to avoid these types of issues, right? To reduce the CPU usage of server, to reduce the bandwidth usage of the link, right? To reduce the CPU on routers as well, between source and destination, whatever devices, networking devices we have, like router, firewall, switch. So we can reduce the CPU on those all devices, right? That is the main benefit of using multicast. Now if you can say, Praful, okay, instead of sending multicast, then let's do one thing, let's send it on the broadcast. Let's send it on broadcast. What if server is going to send on broadcast 255.255.255 at layer 2 as well at layer 3, at layer 3 255.255, at layer 2 FFFFF, right? MAC is destination, MAC is also broadcast, and destination IP is also broadcast. Guys, again, in case of broadcast, if the server is going to send it on broadcast, and many companies, or at many time, like Netflix is broadcasting some services as well as it is multicasting as well, right? So again, see, first we come up with Unicast. First, we come up with Unicast, that is one-to-one communication. That there is one sender, one receiver. That is fine. Then we come up with broadcast, and we shift broadcast to multicast. Nowadays, we are moving all the technologies are moving from broadcast to multicast. All the technologies, right? Let's talk about the RIP, guys. You know RIP version 1 sending their update message on broadcast address, but in RIP version 2 we come up with multicast concept, right? RIP version 2 sends their message on multicast, not the broadcast. So what is the benefit of moving to the multicast from the broadcast, right? Let me give you one example again. Let's say, guys, there are 4 router R1. Here is one switch, and these 4 routers are connected to a multi-access segment R2, R3, and R4. Okay, like this. All the routers are connected in multi-access segment. And on router number 1 and router number 2, let's say we are running, guys, EIGRP protocol. EIGRP protocol. Only on 2 router 1 and router 2, EIGRP and EIGRP. So if the EIGRP is going to send their message on broadcast, what will happen? See, it will generate any message of EIGRP, let's say hello message or update message, query message, reply message, account, doesn't matter. Any message of EIGRP. If the router will send that message on broadcast address, it will forward to switch. Switch will forward one copy to all the router. Correct? Router 2 need this EIGRP message, but router 4 and router 3 does not need this, right? Because we are not running EIGRP here. So router 4 and router 3 are going to drop the EIGRP message, but where it will drop, guys? Where it will drop, right? First, when it will receive the EIGRP packet, it is going to check layer 2 information. It will perform decapsulation at layer 2. At layer 2, it will check the destination MAC. Destination MAC is broadcast. Oh, it can be for me also. If the destination is broadcast, then it can be for me as well, right? I have to check the more detail, more information. So the router number 3 and router number 4 will perform decapsulation at layer 2, and after that it is going to check layer 3 information. Again at layer 3, destination IP address is what? Broadcast. Destination IP is broadcast. So at layer 3 also it can be for me as well, right? So router 3 will accept it at layer 3. It is going to check the protocol field, and then it will see, okay, protocol number is EIGRP. No, EIGRP is not running here. It will discard it. Right? So router 3, router 4, and like this we can have multiple routers here, and those all routers will perform decapsulation at layer 2. It will process the traffic EIGRP packet at layer 2, at layer 3, and then it will discard it, right? For an example, RIP message. RIP message is coming. RIP is an application layer protocol. So when router 3 will receive the RIP message, again layer 2 address, destination MAC address, broadcast. It can be for me also. Destination IP, broadcast, yes, it can be for me as well. Let me check the protocol field, UDP port number. Okay, now it is going to decapsulate the UDP packet also. At layer 4, it will check the protocol value. Protocol value will be 512. Oh my god, this is the port number of RIP. RIP is not running here. Let me discard it. Right? And the RIP or EIGRP, these protocols have some periodic message, right? Like the hello message of EIGRP. Even in the distance vector routing protocol, all the messages are periodic, right? So every time these routers are going to receive the traffic, and after that it will perform decapsulation. It will use their CPU and then discard it, right? Another issue is the bandwidth of these link, guys. Unnecessary switch is sending traffic over here on these links. So instead of sending the EIGRP message on broadcast, if I will send it on multicast, then if you will send it on multicast, then destination MAC will be what? Multicast. Destination IP will be what? Multicast. When router 3 will receive this traffic, it is going to check layer 2 header. At layer 2, destination MAC is multicast. Let me check, am I member of that multicast group? No. If you are not running EIGRP here, this interface will not join the multicast group of EIGRP. It will discard it at layer 2 only. Right? So see how we are saving the CPU utilization of devices. And even in the IGMP, here you have option of IGMP snooping. If you will enable the IGMP snooping on switch will not forward the multicast message to the host who don't need the video stream. So this is the benefit of moving to the multicast from broadcast. And I am expecting the multicasting, guys, basic multicasting. IGMP is one very important protocol of multicasting. So before learning IGMP, you have to understand the multicasting. What is multicasting? Multicasting means one to many, right? Unicast, one to one communication. Multicast, one to many communication, right? One server is going to send same video to multiple device, right? One server sender is one and multiple receiver are there. That is going to be multicast. And broadcast means one to all, right? So we are replacing the broadcast nowadays from the multicast. Multicast is so popular nowadays. Okay. Now we know the benefit of sending the video stream on multicast address. If the server is going to send it on multicast, server have to generate only one packet, only one stream, right? Destination IP will be multicast. Destination IP will be multicast. It will forward to router, and then router can proceed it to the host, right? So guys, see, there are two things. First of all, let's say this server and the host need any type of unicasting, right? Any type of unicast message they want to exchange. First of all, there should be reachability, right? Between the server and host, reachability must be there. For an example, another scenario, let's say here I have one server S1 connected to R1, then connected to R2, connected to R3, and here is switch, and here are the users, right? These users need to access this server. Let's say one application is running here, app1, right? Or google.com, and these PCs need to access the google.com application, right? So how these PC can access this server? First of all, there should be reachability. For the reachability, what you are going to do, you are going to configure routing protocol between the router, right? Routing protocol like EIGRP, OSPF, BGP, ISIS, any routing protocol to make reachability to share the prefixes. That is, guys, called unicast routing. That is unicast routing. Similarly, unicast routing, we need multicast routing as well between the router, right? We need multicast routing protocol. Like we have unicast routing protocol, we need multicast routing protocol, right? And generally we are using PIM. You might have heard about the PIM protocol. PIM is an multicast routing protocol. Like PIM, we have multiple protocol, but we are using the PIM only, right? In PIM, we have dense mode, sparse mode. If you don't know the PIM protocol, sparse mode or dense mode, a detailed information about the PIM, if you need, guys, the detailed video on the PIM also, you can let me know in the comment section. Definitely, I will make one video on PIM as well. Today, we are not understanding the multicast routing, right? Multicast PIM will work between the router like your IGP protocol or EGP protocol, like your IPv unicast routing protocol, right? PIM will work between the router to share multicast stream. Got it? Here, my IGMP protocol will work between the router, your gateway, and host. Here, IGMP protocol will work. What is the purpose of IGMP? It is used to join or leave the multicast group, right? See, what is happening here in this case? Let's say, sorry guys. mm, Mark. Let's say what I am saying, this server is streaming one video, not on the unicast address, now on multicast address, for an example 239.1.1.1, right? We have a range of IP address for multicasting, that is class D, right? And this is the IP address from class D. Like in every class we have some reserved IP address, some free IP address, private, public, right? Exactly like that, in the multicasting in class D also some IP addresses are reserved, like two IP addresses, two multicast IP addresses are reserved for OSPF, one multicast address is reserved for EIGRP. Like this we have so many reserved multicast address. So we are again not going to discuss the multicasting here, right? What is multicasting? Just we are talking about the one topic of multicast, one protocol of multicast, that is IGMP, right? So what is happening? This server is streaming video on this multicast address 239.1.1.1. Done. Router will receive this stream, this multicast stream, but router is not going to send it to switch by default. It will not send to these host. Why? Because these hosts are not the member of that multicast group. Which multicast group? This multicast group. Correct? So if this PC need the multicast, let's say if you want to watch the video which server is streaming, you have to send one join message to your router that okay, brother, hey router 1, hey R1, send me the multicast stream for this group 239.1.1.1. Hey, send me the multicast stream for this group. And like this we can have multiple group. Let's say server is transmitting or sending a stream on another multicast address 228 dot, let's say 10.10.10, right? So server is streaming the video on two different multicast group address, right? Or let's say this PC need the multicast stream for this group. So PC is going to tell to router 1 that hey bro, I need the stream, video stream for this group 239.1.1.1. How router 1 will send this information to router? With the help of IGMP protocol, with the help of IGMP protocol, Internet Group Management Protocol, right? Guys, PIM will work between the router R1, R2. Here, PIM will work between, let's say, router and server, or between router to switch, not between the router and gateway. IGMP protocol will work between host, PC, it can be PC, it can be IP camera or any device, and device, between host and your gateway, means your local router. Here IGMP protocol will work. And between the router, your PIM protocol. PIM is similar like MOSPF. If you know the MOSPF, right? Why we are not using MOSPF and we are using PIM? Because guys, MOSPF protocol is dependent on OSPF, right? It will only work if your unicast routing protocol is OSPF, right? But PIM is independent protocol. That's why PIM is in use nowadays. Okay. So here we will configure IGMP protocol, and here IGMP protocol is required to join or leave the multicast group. For an example, what is 1 minute? Yes. For an example, what I am saying, let's say this person, this is the person whose name is, let's say for an example, um, um, person A. Person A. Guys, person A need to watch the video, right? The video which server is transmitting, right? Server is sending a stream on 239.1.1.1. So this PC need the video, right? It will send the join message to router that hey router, send me the stream, and after that router will start sending the stream to this host, right? This stream which router was receiving from the server. And let's say the person A is now watching the movie, everything is working fine in their bedroom, and let's say their mom came, right? Their mom came and he suddenly closed the application, right? In the real time, guys, how you are going to join the multicast group? By opening the application. If you are going to open the application, if you need to watch the video on YouTube, so you will open the YouTube application. When you will open the application, your device will join the multicast group, right? So when this person will open the application, it will send request message to router, right? Join, that is also called report message in the IGMP. Report message to router that, hey, I need a stream for this particular group, because that application is going to tell to PC that you need to join this group. Okay, YouTube this one, Netflix this one, Aztak this one, like that, right? And if you are watching any video and if you need any video, you will send the join request message to router, and router will start sending a stream. And if you will close the application, it will send leave message. It will send the leave message to router that, hey bro, now I don't need the stream, please stop sending it. And then router will stop sending the stream, right? So we have three version in the IGMP protocol. IGMP version 1, version 2, and version 3. Okay, in version 1, guys, we don't have leave message. We don't have leave message, so there is leave latency. To avoid the leave latency, we come up with version 2 with leave message, right? In version 1, we have only two messages. One is query message and another one is join message, right? In version 1, B1, we have two messages. First one is query message, which is periodic in nature, right? Sent by router. Your router will be always sending query message after every 60 seconds. 60 seconds or 30 seconds, you can check that in book, right? But router is sending periodic query message to the host, right? Just to ask to the host that, he is there anyone who need the stream for this group 239.1.1.1. In the query message, it will share multicast group, right? And if any user need the stream, they will respond to the query message with which message? With the join message, or report message, you can say report message. In the Cisco book, you will find report message, right? Or another option is, let's say this PC quickly want to watch the video, so it will not wait for the query message of router, it will send their join message. Once you will open the application, it will send the join message. But after again every 60 second or maybe 30 second, I am not sure about that time, router will send query message, and these host will be generating the report message in response of query message. And until and unless router will be receiving the report message, it will be sending the stream. It will be sending the stream. If there is no one watching the video, right, or let's say all the users have closed the application, right, all the users have closed the application, so router will generate query and no one is going to generate report message. So if router will not receive report message or join message for three consecutive query message, then router will stop sending a stream. What I am saying, if router will not receive report message for three consecutive query message, then router will stop sending a stream. But guys, again here we have one issue. Try to understand what is the issue now. Issue is, okay, Praful, after every 60 second, a router is sending one. After every 60 second, router is sending query message. Query message, fine. And every user is going to generate report message or join message. So again, Praful, here we have flooding, right? So many, if 100 users are there, so all the 100 users are going to generate report message after every 60 seconds, right? So unnecessary bandwidth utilization is there, right? Bandwidth usage. How we can reduce this? So guys, we can reduce this. That's why we come up with version 2. In version 2, we have lib message. When first of all, whenever any user will close the application, it will send the lib message to router. Let's say this PC have closed the application. So it will send the lib message to router, but router will not stop sending a stream, because still some users are there who are watching the video, right? So it will not stop sending a stream. When router will stop sending a stream, see, first of all, we need to suppress these response messages, guys. We need to suppress these response messages. So main purpose of version 2 is, see, in version 2 we have 4 messages. Again, query message, same use of query message, periodic in nature, send it by your local router to the host to ask that is there anyone who need video stream for this particular group. Okay, then now we have join message. Again, join message or report message, you can say report message. And then here we have added some more message, 2 message. Third message over here is leave message, leave message. That's why I'm saying IGMP protocol is used to join or leave the multicast group. And the fourth type of message is here, group specific message, specific group message. To understand this, let me give you one example again. Okay, see what will happen, how it's working, how IGMP protocol works. IGMP. See, when router 1 will send the query message, right, there will be one field, guys. Which field? MRT field. MRT stands for max response time, right? It will send MRT with query, max response time, and this value is 10 seconds. In version 1, you are not allowed to change this timer, MRT time, but in version 2, you are allowed to change this time. You can configure from 1 to 255 seconds, 0 to 255 seconds in version 2. But in version 1, MRT will be always 10 seconds. You are not allowed to change it. Now, when these hosts will receive the query message, guys, all the hosts are going to set one time between 0 to 10 seconds. All the PCs hosts are going to set one time. Let's say this PC1 has set their time to 2 seconds. 2 seconds. This PC has set their time to 5 seconds randomly. This is random selection of time from the range of MRT, right? First PC time 2 seconds, second PC time 5 seconds, third PC time is, let's say, 10 seconds, and the fourth PC time is, let's say, 7 seconds, right? Randomly all have selected one time between 0 to 10 seconds, okay, for the query message. And the host who has the lower time, like PC1, will generate response message. When it will generate the response message, when this time will expire after 2 seconds, it is going to generate join message or report message, right? We can say report message, right? It will reach to switch, and switch will forward it to router. It will also forward to other host. And once these hosts will receive the response message from PC1, these hosts are going to suppress their report message, right? These hosts will suppress their report message. That means these PCs are not going to send the report message to router, right? So this way we are avoiding the number of report message or join message after for the query message, because otherwise after every 60 seconds router is sending query message, and all the host will generate reply, give reply, means join message or report message. To suppress it, what we did, we come up with MRT concept, max response time concept, right? When router will send the query message, it will also send the MRT value, and all the host will set a timer, random time from 0 to 10 seconds, and the host with the lower time will generate the response message. And the router will receive response message from which PC, guys? From the host 1. What is the IP address of host 1? 10.1.1.1. 10.1.1.1. So router knows that, okay, I am receiving report message from PC1 from the host 10.1.1.1, right? That is going to be reporter. right? That is reporter. In IGMP, PC1 is your reporter. After 60 seconds, again when router 2, router 1 will send the query message, at that time maybe another PC will be the reporter, right? The PC who will set lower time, that PC will become reporter on router number 1. So router 1 know that okay, reporter is 10.1.1.1 because I received join message or response message or report message from PC1. So let's say if this PC is going to leave the group, if we have closed the application on this PC, what will happen? This PC will generate leave message to router. Router will check the leave message. Okay, someone don't need the multicast frame. But guys, in the LAN side, other users are still there, right? The reporter is 10.1.1.1. This leave message doesn't come from reporter. That means reporter is still there who need stream. So router will be keep sending the stream. It will not stop sending the stream if any user will generate the lib message except the reporter, right? Now if reporter is going to close the application, then what will happen? If reporter will close the application, then again reporter will send lib message to router. Router will say, okay, now my reporter has left the group. Is there anyone else who is watching the video? Because earlier router had one entry that okay, this is my reporter 10.1.1.1 who have given me the respond, right, report message or join message. So that's why I'm sending the stream. If the reporter is going to leave the group, router will send this query message, group specific query message, right, to again ask, is there anyone else who is watching the video who need the stream? And then host will again send the respond message, report message or join message. Again the reporter can be another PC, let's say 10.1.1.2, right? And it will have entry that okay, my reporter is 10.1.1.2. So router send periodic query message after every 60 seconds, and one host, which is the reporter who has lower time, will generate the respond message to router. And after every 60 seconds, router is sending new query message, so reporter can be changed. Reporter can be changed. And if reporter will leave the group, whenever reporter will leave the group, router will send group specific query message, right? Okay, so let me revise you again the version 1 and version 2 IGMP. IGMP, what is IGMP? IGMP is a multicast protocol used between local host and local router, means your gateway, between end devices and gateway. There are two versions, version 1 and version 2. And I also told you there are three versions, version 3. Guys, again in version 3, we come up with some additional feature, like in version 3, you can also filter the source, right? That is the additional feature of IGMP in version 3. Otherwise, version 3 also works like version 2. We have the same messages there as well, right? So in version 1, we have a query message and join message. In version 2, we have query message, we have join message, and we have leave message. And one more message when reporter will leave the group, that is group specific message. Group specific message. Okay, hope it is clear. These are the theory of IGMP protocol. Now let me tell you the theory again. In the note I have mentioned these all things. Let me show you. What happened here? Okay, yes, see. Okay, what is saying? IGMP IGMP is a protocol used by device to join or leave a multicast group. Hope this is clear. It works between host like a computer, IP camera, etc., and the local router. It helps router to know which device want to receive multicast traffic for a specific group. After that, why do we need IGMP protocol? Multicast traffic is sent only to devices that want it, right? Not like broadcast, which goes to everyone, right? This is multicast, guys. Multicast message will be traffic is sent only to the devices that want it, right? If we are not running the EIGRP on router 3 and router number 4, that router will not get EIGRP message. Okay, then so IGMP helps router know who want what, right? Like who want what means who want stream and stream for which group, right? Which multicast group. Okay, and only send that multicast stream to the right receiver, not to everyone, right? Here is an example of company. Hope it is clear now. No need to discuss the example. And let me show you the NOC configuration. See, guys, in this topology, I have already configured the IP addresses, right? Even routing is not required. First of all, let me access the PC1, and see on the PC1. Let me ping the server. Server IP address is 192.168.1.10, and server IP address is subnet between router 1 and server is this one, 192.168.1.0/24. Dot 10 is running on server and dot 1 is running on router. And in the LAN side, my subnet is 10.1.1.0/24. Dot 254, the last IP address from the subnet is running on router, which is the gateway for these PCs. On PC1, you can see dot 1, PC2.2, PC3.3, and PC4.4. Okay, and let me ping the server from PC1. Ping 192.168.1.10. Ping is not, sorry, IP address is not configured here. Let me configure the IP very quickly. Interface F0/0, no cert, and IP address on PC number 1, 10.1.1.1, and 255.255.255.0. No IP routing. Here I am disabling the routing because this is host, and IP default gateway IP address will be router 1 IP address 10.1.1.254. And now let me ping the server. Ping 192.168.1.10, and I am expecting reachability. Yes, you can see ping is working. That means we have reachability between the host and server. We have reachability between host and server, guys. Now from the server, I am going to send some multicast message. How you will send the multicast message? See, let me take you to server first. Here is my server, and let me say ping, and ping to any multicast address. Let's say 239.1.1.1. If I am going to ping to this multicast address, you can see, guys, ping failed. Ping is not working, and when you are pinging to multicast address, your device will only generate one ICMP packet. You can see one ICMP packet is there, right? So let me do one thing. Let me send lots of ICMP packet from here. Repeat, I'm saying 10,000. Ping is not working. Because why ping is not working? Because there is no one who need the multicast stream who is listening on this group. There is no one, guys, who is listening on this group. So you have to join this multicast group to the PC, right? We'll configure it. But before that, let me enable IGMP protocol on router number 1. Let me take you to router 1, R1, and here show IP IGMP interface. So you can see IGMP protocol is not enabled on any interface of router 1. Not enabled, right? Even the PIM protocol is not enabled. This is router. On the router, you will configure PIM, right? So let me enable PIM here. Interface range F0/0 and F0/1. Guys, if you need a detailed video on PIM as well, just let me know in the comment section. F0/0 and 1. Definitely, I will make one detailed video for PIM. That is multicast routing protocol. PIM is a multicast routing protocol. Okay. So here I am saying IP PIM, and then let's say dense mode, right? In the PIM we have two mode. See, I'm not able to run this command because it is giving me the warning that multicast routing is not configured. Multicast routing is not enabled on your router, right? Even you can check it by running command show IP multicast. So what it's saying, you can see multicast routing is disable. Multicast routing is disable. Multicast multipath is disable. Route limit, okay. Routing is disabled. So let me enable the multicast. See guys, another multicast routing protocol is DVMRP, right? Again, this protocol is dependent on distance vector routing protocol, but your PIM is independent protocol. Let me enable the multicast routing here first. Command to enable multicast routing is going to be IP multicast routing, right? So this command will enable the multicast routing. Now you can verify. So IP multicasting, you can see now multicast routing is enabled. And now let me enable the PIM on the router interface. Interface range F0/0 and F0/1, and here I am saying IP PIM, let's say dense mode or sparse mode, any mode you can enable. And now you can check the IGMP. So IP IGMP interface. Now you can see IGMP protocol is enabled on which interface? On fast Ethernet 0/0. Here you can see current IGMP host version is 2 and the router version is also 2. Okay, IGMP, and it is sending query message after every 60 second, guys. 60 second. Okay, so now done. Here if you will capture this link, even you will find the IGMP query message. Let me show you the capturing. For a moment, I am capturing this link. Okay, here is my capturing, and you can see the query message. Router 1 has started sending IGMP query message. If you will open this query message, see in the query message source IP address is 10.1.1.254 and destination IP address is 224.0.0.1. Guys, this is very important multicast address. Now this is question for you. This multicast address is used for which purpose? What is the purpose of this multicast address? 224.0.0.1 and 224.0.0.2, right? Tell me in the comment section what is the purpose of these two multicast address, 224.0.0.1 and 224.0.0.2. Okay, and so okay, this is the IP header. In the IP header, source IP address is the IP address of router 1 exit interface, and the destination IP address is multicast. This is not the group address, right? Now let me open the IGMP message. Here you can see this is IGMP message, and here guys group address is 0.0.0.0, right? Means no group, correct? There is no any group. And again you can see it is sending, and this time multicast address in the IGMP message is 224.0.0.0.1.40. Again this is important multicast group. This is which message? This is report message. This is not query message. This is report. Here is your query message. Okay, now what we'll do? We'll do one thing. See on the server, ping is still not working. It is sending the traffic. Even if you want to see the capturing, here you can capture this link as well. Yes, you can see server is keep sending ICMP message, right? With the, on which address? On this address 239.1.1.1. But guys, router is not forwarding it to the switch. Router is not forwarding it to the switch because we are not able to find this multicast address on this link. Right? This is the link between router 1 and switch. This is the link capturing between server and router. So server is sending the multicast stream, but router is not forwarding it to switch because there is no one who want to receive this stream. So what we'll do, guys, we will configure PC1. What is happening? Don't know why. What we will do, we will configure PC1 to join this multicast group. Let me take you to PC1 and go to interface F0/0, and on the server, what is happening? Okay, server is, you can see, keep sending ICMP message on this multicast address, but PC, there is no one who want to join the stream, this multicast group, who want to receive the stream. That's why router is not forwarding. Now I am going to join this interface to this multicast group. Say IP IGMP multicast, sorry, IGMP join group to which group? 239.1.1.1. And soon you will start getting reply on the server. Yes, now you can see on the server we started getting reply from the PC. Right now PC is generating reply, and here is the capturing, guys. In the capturing you can see we are able to find the reply message and query message between router and switch. And here is your report message. You can see which device has sent this report message. Your 10.1.1.1 means host 1, destination the multicast group 239.1.1.1. what it's saying, I want to receive a stream for this group, I want to receive multicast message for this group, and then router will start sending the stream. Getting my point? Similarly, another PC can also, now you can see server is only receiving reply from 10.1.1.1. Let me do one thing from PC number 2 also. I am going to join the multicast group to PC 2. Video length is getting, guys, lengthy. I should divide this in two parts, but no worry. Interface F0/0 no cert and IP address 10.1.1.2 255.255.255.0 and exit no IP routing. First of all, let me disable the routing and let me configure IP default. Gateway 10.1.1.254 and then interface F0/0, and I am saying join IP IGMP join group. Which group? 239.1.1.1, right? And now you can just wait. Yes, here now you can see I started getting reply from 10.2 as well, right? So whenever a host need the multicast stream, host will send what? Host will send the join message to the router, right? Here somewhere you will find the join message. Yes, see, report message and join message both are same. Okay, guys, so hope now you know the IGMP protocol, the basic about IGMP, and with the configuration, with the lab, their messages, and version 1, version 2. What is the difference in version 3? Here you can see I have mentioned that version 1, version 2, and version 3. Yes, version 1 has basic support, join message and no leave message. Basic join support, right? Means host can join the multicast group, that's it, no leave message, right? Router uses timer, right? In version 1 we will have leave latency. Whenever any user will close the application, want to leave the group, right, it cannot send the leave message. So router will stop sending the stream after, guys, 180 seconds. Let's say all the LAN user has closed their application. So when router will stop sending a stream after 180 seconds, when it will not receive the join message or report message after sending three consecutive query messages, right? So that is called leave latency. Leave latency, right? So to avoid the leave latency, we come up with IGMP version 2. IGMP version 2 adds leave message and quicker responses message. This is exactly same like group specific message, leave message. And then in version 3, version 3 adds some support for source filtering, right? I want traffic from this source only. But definitely, guys, in the real time we will not have only single server for one video, right? We will have lots of server. For an example, Aaj Tak news channel, will have multiple servers for the same video, right? So version 3 allow you, or like that is again another concept for here. Let's say R1 and R2, there are two gateway. There are two gateway in the LAN side. There are two gateway in the LAN side. So the user can have two gateway. It is receiving. It can receive the stream from two gateway, right? So in that case, you can not receive the stream from a specific source. Here we cannot filter the source in version 1 and version 2, but version 3 allow you to receive the traffic stream from a specific source. There are some more differences and some more concept of IGMP, guys. Definitely if you need video for any other topics or PIM or the detailed multicasting, or maybe you need a complete course for multicasting, just let me know in the comment section. Whatever query concern you have, you can let me know in the comment section, and definitely I will try to make video on your topic as soon as possible. That's all for today, guys. Now last request is, if you have learned something from this video, if PM networking videos are helping you, then please hit on like button and share your feedback in the comment section, guys. Your positive feedback always motivate me to work hard and make more videos. Okay, that's all for today. Thank you so much for watching. We'll meet soon in the next video, guys. Till then, stay safe. Bye bye.